I designed this project years ago, one of the first things I ever created in Rhino. Today, after all this time, I want to come back to it and take another look. Where did this form actually come from? How did it evolve into its final shape? And if we were to rebuild it from scratch today, what process would we follow? Let's get started. Hi, I'm Hossein, and welcome to my YouTube channel. A few days ago, I was going through one of my old hard drives, those ones usually filled with forgotten files, old projects, and memories from my student years. Among all those files, I suddenly came across a project that really took me back. It might not be the best project I've ever done in terms of design or presentation quality, but it has one very special feature. It was the very first project that introduced me to Rhino. In fact, this was the first time I was able to take an architectural idea and properly model it in Rhino in a structured, presentable way. On the surface, it may look simple, but for me, it marked the beginning of a long journey, a journey that later shaped a big part of my professional and teaching career. When I revisited the files, I started thinking that maybe it shouldn't just stay as a memory. Why did this project take shape? Where did the initial idea come from? How did the final form emerge? And most importantly, if we were to rebuild it today, using modern tools and workflows in Rhino, what process would we actually follow? That's why I decided to turn this old project into a video and share the entire process with you. In this video, we'll talk about the idea and concept behind the project, explore how the form was developed, and finally rebuild it in Rhino to see how we would approach it today. I think beyond revisiting an old project, this can also be a useful exercise in form analysis and learning 3D modeling. So without further delay, let's jump into the project and see where it all began. Before we move into the design and modeling process, it's worth briefly talking about the project itself. The project was the design of a 25-story residential complex. At the time, it was one of the largest and most complex projects I had worked on, at least for me. Because unlike smaller assignments, this wasn't just about designing a single building or a few simple plans. We had to think about multiple layers of problems, how the building sits on the site, how the residential spaces are organized, vertical circulation systems, daylight access for the units, views and visual connections, public and semi-public spaces, and ultimately the form that needed to integrate all of these ideas. High-rise design always comes with its own challenges. Every decision you make in the building's form can directly affect the quality of interior spaces, lighting, views, structure, and even the overall living experience of the residents. That's why, unlike what we sometimes see in architectural renders, form is not just a beautiful shell, it is the result of a series of design decisions. This project was part of Studio 5 during my undergraduate architecture studies. At that time, I didn't have much experience with large-scale projects, and naturally many of the decisions I would make today are different from the ones I made back then. But what makes this project interesting to me is that you can actually trace the process of thinking and idea formation within it. In fact, this project is less about a 25-story building itself and more about a snapshot of my mindset and design approach at that stage of my studies, how I approached a design problem, and the path I took to reach an architectural form. Now that we understand the context of the project, let's see where the initial idea came from and how the form gradually started to take shape. If I want to talk about the challenges of this project, it wasn't just an academic exercise for me. It actually marked a few important turning points in my learning process. The first challenge was my early interest in bionic architecture. I was always fascinated by architectural forms inspired by nature and organic structures forms that are not just geometric or rigid, but carry an underlying logic of growth and natural behavior. This project was one of the first times I seriously tried to bring that way of thinking into my design process. In a way, it became the starting point of my later research path, to the extent that even in my master's studies, I chose architectural technology with a focus on bionics and continued in that direction. The second challenge was related to tools and software. At that time, most of my work was done in 3ds Max, but gradually Rhino 5 was emerging as a serious tool for parametric and form-driven design. At the same time, one of my professors strongly encouraged me to move beyond purely rendering-based workflows and explore more precise tools for form generation. That was the moment I decided to switch to Rhino. In fact, this project coincided with a major shift in my working method, both in how I thought about form and architecture and in the design tools I used. And it was exactly this combination that made the project more than just a class assignment. It became the starting point of a new direction in my design and modeling process. So the key question is, how did we end up with this final form? To answer that, we need to go back to the concept and ideation stage. The core idea of this project was rooted in Bionic architecture. Instead of starting from a purely geometric or functional logic, I tried to derive the form from natural systems and patterns. In this project, my main source of inspiration was the morning glory flower. For me, it wasn't just a visually interesting shape. What mattered more was its way of growing, opening, and closing its organic behavior. A structure that, despite its simplicity, carries a living and dynamic logic. That's what made me think it could be translated into a residential high-rise system. At this point, it might be useful to briefly explain what bionic architecture means. Bionics in architecture refers to using patterns, structures, and logic found in nature to solve design problems. Instead of treating form as something purely invented by the designer, it is derived from systems that have evolved over millions of years, systems that already provide highly optimized solutions to complex problems. After this initial idea was formed, I moved into what was probably the most important phase of the entire process, generating alternatives. At this stage, I started testing different forms in Rhino. The goal was to see how this bionic idea could actually be translated into a real 25-story building. I explored multiple directions, some forms with spine-like structural logic, others more complex and twisted, and even some simpler and more controlled versions. I basically pushed several design paths in parallel to understand which one made sense, both aesthetically and functionally. This phase felt more like a design laboratory, where forms were constantly generated, adjusted, and redefined until eventually a coherent formal language started to emerge. If you've made it this far into the video, thank you for watching. If you found this kind of content useful or interesting, you can support the channel by liking the video and subscribing. And by hitting the bell icon, you'll make sure you don't miss the next episodes. It might seem like a small action, but for me, it really matters. It helps me understand what kind of content is actually valuable to you, and it allows me to continue producing videos like this with more energy and focus. Let's get to the final form of the project. What I eventually arrived at was a direct result of all the tests and alternatives I explored in the previous phase, but now refined through a set of clearer constraints and design decisions. There were a few key parameters that were very important for me. First, at the lower levels where the lobby and public spaces are located, I needed a relatively large floor plate, around 2,500 square meters. This space essentially acted as the base and main entrance of the complex, giving the building a stronger sense of scale and presence. At the very top, there was a standalone penthouse, a 900 square meter unit, which represented the spatial and visual climax of the project. In total, the project included around 150 residential units, along with several commercial units placed on the lower levels. By combining these requirements, the final form gradually started to take shape, a form that had to both accommodate a high number of units and still maintain a unified architectural language. The unit distribution across the floors was structured like this. From floors 2 to 3, there were 6 units per floor. From floors 4 to 7, this increased to 8 units per floor. From floors 8 to 10, it became 9 units. From floors 11 to 16, it went back to 8 units. From floors 17 to 19, there were 4 units per floor. From floors 20 to 22, only 2 units. And finally, from floors 23 to 25, each floor was dedicated to a single unit, the penthouse. Of course, I should emphasize once again that this is a student project from my undergraduate years. Like any academic work, it comes with its share of design flaws, technical challenges, and even contradictions in some parts. Looking back at it now, some of those decisions even feel a bit amusing. For example, one of the most obvious issues, aside from structural or execution concerns, was the limited number of elevators in the central core. which was clearly not sufficient for this number of units and could have become a serious bottleneck in a real-world scenario. But the goal of this video was never to present a perfect project. I simply wanted to share this early work with you, and more importantly, explore how such a form can be modeled in Rhino and what kind of logic sits behind its construction. All right, now let's move on to the exciting part of the modeling process in Rhino. To start, I always begin with an initial envelope or a base mass. That's exactly what I did in this project as well. The first idea was to create a shell-like surface that defines the overall form of the tower. I achieved this using the loft command in Rhino. The workflow is quite simple. You draw a series of closed profiles at different heights. These profiles can change depending on the concept of the project. Then, using the loft command, these curves are connected together to generate a smooth, continuous surface. And now, I'll use the twist command to rotate the form by 90 degrees, giving it a subtle sense of movement and rotation. Once this primary outer shell was created, I needed to give the form a more dynamic, terraced character, so I duplicated the surface inward. I did this by holding Alt and using the scale function with the gumball, creating a slightly smaller inner version. The space between the outer and inner surfaces is where the terraces are formed. In this project, I kept a distance of about 2 meters, which gives each unit a usable terrace, improving spatial quality, while also reinforcing the idea of green architecture and connection to the exterior. After that, I moved on to the floor division. I sectioned the surface every 4 meters, since each floor was approximately 4 meters in height. Then I extruded these contour lines by about 50 centimeters to generate the slab for each level. What's interesting is that with this simple method, you can generate almost infinite variations of form. If you change the profiles, for example, using more fluid or even circular shapes instead of smooth ones, the result becomes completely different, but the underlying logic stays the same. That's exactly what I did in this project. I defined the profiles based on the required floor areas at different heights and placed them accordingly. Then I created an inner shell with a 2-meter offset to form the terraces. Finally, I sectioned the surface, separated the floors at 4-meter intervals, and extruded the resulting curves. With this approach, the initial tower form emerged, and at the same time, I also generated a set of base floor lines that could later be used for designing the individual unit layouts. So in a way, we weren't just generating form, we were also producing a first layer of data for the interior design process. So in the end, what actually happened? This project wasn't just another university assignment for me. I would say it became one of the turning points in my academic and professional journey. It was a difficult experience, time-consuming, and at times quite exhausting, but at the same time, extremely educational. One of the main challenges was that the floors were not repetitive. In other words, each level had a different form and layout, which meant I couldn't rely on a single repeating floor plan. I had to design all 25 floors individually. That made the process both heavy in terms of time and demanding in terms of precision. But that difficulty led me to a much deeper understanding of the relationship between form and plan how. When the form changes, the plan is no longer just a byproduct, but becomes part of the design process itself. On the other hand, this project also had a strong influence on my future direction. After this experience, my interest in bionic architecture became much more serious, and eventually I pursued a master's degree in architectural technology with a focus on bionics. I can actually say that this project was one of the first sparks that shifted my approach from purely formal design toward design based on natural logics and more complex systems. At the same time, it also marked the beginning of a longer journey with Rhino. After this project, I became deeply interested in the software, and much of the work I did afterward can be seen as a continuation of this initial experience. So, if I want to summarize it, this project might not be perfect in terms of its final output, but in terms of its impact on my career path, it remains one of the most important experiences of my student years. So you might be wondering, what was the final result and what grade did I get? Honestly, despite all the challenges, the workload, and the complexity I was dealing with throughout the semester, My professor was very satisfied with the design process and the overall progression of the project. What mattered more than the final output itself was the thinking process, the way the form evolved, and how problems were approached and resolved during the term, and that was exactly what I had focused on. In the end, I received a full grade for the course. But more important than the grade was the experience itself, how a simple idea can gradually turn into a complex architectural project, while simultaneously reshaping both your approach to design and your understanding of the software you use. Thanks for staying with me until the end of the video. I want to emphasize one more important point here. The purpose of this video was by no means to approve or reject this architectural project. This work was done about 15 years ago, when I was still a second-year student. Naturally, like any early stage experience, it is full of trial and error, mistakes, and overly simplistic decisions. The main goal was to share my first experience with Rhino, and also to show how a student project can become a starting point for deeper learning and a more professional design path. I would really love to hear your thoughts about the video. I read all the comments and try to respond whenever I can. If you found this video useful or interesting, you can support the channel by liking and subscribing. It really helps me stay motivated to continue producing this kind of content. See you in the next video. Goodbye.